Okay, question 1. Subbing the x values into the equation, x plus 1, so 1 plus 1, 2, 2 plus 1 is 3, 4, and then 5. What are the x and y coordinates of A? So x first, so 3, 7, and it must be in a bracket. B, negative 3, 3. C is 5, 0. D is negative 2, negative 2. And E is 3, negative 2. Now question 3, because it says use the table and then plot the points, we have to do it that way. If you didn't want to do it and you wanted to use the gradient and y-intercept, you could do the y-intercept first at negative 2. You have a gradient of 3, which is 3 over 1, which is rise of 1, 2, and 3, and a run of 1. Put a dot there and join them up. Now, because we want to plot the table, 0, obviously 0, shove it in, you always get the y-intercept, negative 2. Now the gradient is 3, so that means it goes up by 3. So therefore 1, 4, and 7. But obviously you can plot those points anyway. So 0, negative 2, 1, 1, 2, 4, and 3, 7. And we can graph that line as best as possible with a ruler. If you want to continue, it needs to be this point down here. And add it with arrows. Okay, question 4. Using the table, y equals 5. So x has no effect on it, so it doesn't matter. It's always 5, which is through a horizontal line through y equals 5. Question 5. The y-intercept is 4, y equals 4. The x-intercept, where it cuts the x-axis, is x equals negative 2. Now, y equals 0. Y equals 0 is along the x-axis, because y equals 0 is just there, anything relating to that. And x equals 0, which is just also on the origin, is anything on the y-axis. Okay, gradient of the slope, rise over run. So we can do a right angle triangle to get from this point to this point, or the other way around. We can rise 3 and run 2, but we must run in the negative direction. So we get 3 over negative 2, which is the same as negative 3 on 2. Now use Pythagoras theorem, so we have 3 squared plus 2 squared. Now the negative does not matter because it's distance. 3 squared is 9, plus 2 squared is 4, which is 13, and we must square root. And the square root of 13 is 3.605. We want it to 2 decimal places, so 3.605, the 5 rounds it up to 1. Use the formula. Because it says use the formula, we are going to use it. The midpoint, okay, x1 is the first x value, which is 1, plus the second x value, which is negative 2, all over 2, because mid is just an average. The first y value, which is 2, plus the second y value, which is 4, again over 2. 1 plus negative 2 is negative 1, over 2 is negative a half. 2 plus 4 is 6 over 2 is 3. Now the gradient, y2, is 4. Take away y1 is 2. The second x value is negative 2. Take away the first, so we get 2 over negative 3, which is the same as negative 2 on 3. The distance, square root of x2, which is negative 2, take away 1, all squared, plus y2, 4, take away y1, all squared. Now negative 2 minus 1 is negative 3, and if you square that you get positive 9, plus 4 minus 2 is 2, square that you get 4, you end up getting the square root of 13. Now you can make that into decimal points, but it doesn't actually say, so we're going to leave it exact. Okay, what is the gradient and y-intercept of? Okay, y equals mx plus b, so the m, the gradient, is the number next to the x, so we've got negative 7, and the y-intercept, the plus b, is positive 14. Two equations that are parallel, same gradient, so the same negative 7. So y equals negative 7x, and y equals negative 7x, plus 1, minus 2. They can be any random ones. Okay, convert to general form. So we look at the x. It is negative, so it needs to go to make it positive. So we're going to get positive 3x. The y is already there, so it's positive y. And the 8 needs to go over 2. And it all must equal 0. Now question 10, find the equation of the line with gradient of 7 and go through that point. So therefore, we can either use y equals mx plus b, so y equals mx, so it has to be 7x plus something. Now, we're going to use this point here, and we know the x value is 2, so we're going to do 7 times 2, which is 14. But we need a y answer of 1. So how do you get from 14 to 1? You need to subtract 13. Or we can use the formula, the point gradient, y minus y1 equals mx minus x1. That's when you have a gradient and 1 point. So we get y minus your y value, which is 1. Your gradient is 7, x minus your x value, which is 2. Y minus 1 equals, expand the brackets, 7x minus 14. You need to add 1 to both sides, and you get y equals 7x minus 13. Now 11. Write the equation of each straight line. So y equals mx plus b. So if we look at a, always go for the y-intercept first, which is negative 3, so it's minus 3 on the end. And the gradient, which is rise over run, you can choose any 2 points on the line. I'm just going to choose these two here. We rise 2 and we run 1. 2 over 1 is 2. For b, we have a y-intercept of negative 2. Choose any 2 points on the line. I'm going to choose those two. We rise 1 and we run 1 in the negative direction. 1 over negative 1 is negative 1x or negative x. C, we have a y-intercept of positive 1. Our gradient, again, choose any 2 points. Rise of 3 and a run of 1, so therefore we have a 3. D, now D goes through the origin, so y equals, it has plus 0, which obviously you don't need. Now the gradient, we have any 2 points. Now I'm going to choose the origin and this point up here. So we rise 5 and we run 3 in the negative, so therefore we have negative 5 on 3. Now with those I would normally probably start from the origin, from the y-intercept and do my rise over run, but because it's a little crowded I just chose random triangles anywhere. Now 13, equation of line, y equals mx plus b. Now we can use the point gradient formula, but it's best to do this in our head. So already we know that we have a y-intercept of positive 1. And our gradient, rise of 3, compared to a run of 1, 3 over 1 is 3. Number B. Okay, we don't have a y-intercept, we don't have a 0 on the x, so we do a gradient first. We have a rise of negative 2 and a run of 1, so that is negative 2 over 1, which is negative 2. Now, we must choose an x value, so we're going to choose 5, and we must get an answer of 3. So we sub 5 there. Negative 2 times 5 is negative 10, but we need an answer of 3. How do you get from negative 10 up to 3? We must add 13. And C, we have no y-intercept, so we have a rise of 6 and a run of 3. 6 over 3 is 2. Now choose any x value. I'm going to choose 9. Sub it in there. 2 9s are 18, but I need an answer of 15, so I must take away 3. Okay, find the equation of a line through the midpoint of the interval, and which is parallel. So what's that basically saying is that we have 2 points, 3, 5, and 7, negative 3, which is about there. The middle of those, we have a line that goes through that is parallel to this line. So we need to rearrange this line so it's in y equals mx plus b. So let's take away the 2x, so we get 3y equals minus 2x plus 7, and divide by 3, and we get y equals negative 2 on 3x plus 7 on 3. So basically that line looks something like this. So we need to know what the equation of this line is, because it's got to go through this point. Okay, so we're going to use the point gradient because we know the point. We're going to find that out, and we know the gradient, which is parallel, so it's got to equal that one. So we've got a gradient of this, and we need to know the midpoint of these two. So add the x's together. 7 plus 3 is 10, divided by 2 is 5. Add the y values. 5 plus negative 3 is 2, divided by 2 is 1. So we have a point and gradient now. So y minus y1. So y minus 1 equals m, the gradient, x minus 5. Now, you can either do this in the general form, where you would multiply the other side by 3, and then expand the brackets, or the y-intercept gradient formula. So let's do the y-intercept gradient formula. So y minus y1, expand the brackets, we get negative 2 on 3x plus 5 times 2 is 10 on 3. How do you get rid of minus 1? We're going to plus 1, and we get y equals negative 2 on 3x plus 1 whole to that is 3 on 3, so you get 13 on 3. Otherwise use your calculator. Find the equation of the straight line which contains the points that. So that's just basically saying that the line goes through both of those points. So we need to know the gradient. So rise over run, or y2 minus y1. Doesn't really matter. How does it get from 4 to 8? It rises 4. How does it get from 2 to negative 6? It goes down 8, which is the same as negative a half. So y minus y1. Now it doesn't matter which point you use, it'll get the same answer. So we're going to use the first point. Y minus 4 equals m x minus the 2. Y half x plus half of 2 is 1. Add 4 to both sides, plus 5. Write an equation of a line that is perpendicular. So therefore, we know this has a gradient of 2. If it is perpendicular, it is the negative reciprocal. So that's negative and flip. So it has to be y equals negative, flip 2 over 1 becomes 1 over 2, x plus any number you want. We don't even have to have that. Write the equation of a line that is perpendicular to this. So again, we have a gradient of negative 3 on 4, so negative reciprocal of that would be a positive 4 on 3x, again plus any number you want. Find the equation of a line which is perpendicular and passes through the point. Okay, so we know the gradient of this line is negative 2, so we need to get the perpendicular line. So therefore the gradient that we need will be the negative reciprocal, so positive 2 over 1 becomes 1 over 2. And the point 2, 3. So point gradient formula, y minus y1 equals 2 x minus x1, sorry, half the gradient is. So expand the brackets, we get a half x, take away 1, add 3 to both sides, half x plus 2. Now, again, I'll do it for this one. Because we knew the gradient, we could do y equals mx plus b. So y equals half x plus something. We know it goes through 2, 3, so we need to sub in 2 where the x is. Half of 2 is 1. How do you get from 1 to 3? You add 2. Now again, that's fine for this question, but it's a bit harder for ones which contain harder fractions. Find the equation of a straight line which goes through the point 1, 5 and is parallel to the straight line that goes through this. So if it's parallel to this, it means it has the same gradient as this line. So the gradient of this line is rise over run, so from 4 to 8 is 4, from 2 to negative 6 is negative 8, which gets you negative a half. So we know it's parallel, so it's the same gradient, and it goes through 1, 5. So y minus y1, which is 5, equals gradient x minus 1, y minus 5 equals, actually I want to change that. I'm going to do the general formula just to change it up. So general formula must have whole numbers, so I'm going to get rid of the divide by 2. So I'm going to times by 2 over the other side, so I get 2y minus 10 equals, I'm going to be left with negative 1. Then I'm going to expand the bracket so I get negative a half plus 1. Now, general form, x must be positive. It isn't, so it needs to go over the other side. So x plus 2y. This needs to also come over. How do you get rid of plus 1? You minus 1. From minus 10 gives you minus 11. Now the last question, prove that these points form a parallelogram. Now we could draw it, but quickly, parallelogram, really easy to prove. You can either prove that that equals that, and that equals that, but distance is a little bit harder, or that is parallel to that, and that is parallel to that, which is really easy. So the gradient of AB is rise over run, so 6 minus 4, or how do you get from 6 to 4? We rise 2. How do you get from 3 to negative 1? It's down 4, which is the same as negative a half. The gradient of BC from 6 to 2 is negative 4. From negative 1 to negative 4 is negative 3, which gets us positive 4 and 3. The gradient of CD from 2 to 0 is negative 2. From negative 4 to 0 is positive 4, which gets you negative a half. And the gradient of AD from 0 to 4 is 4. From 0 to 3 is 3. Now you'll see that this gradient is the same as this, which is parallel, and this gradient is the same as this, which is parallel. So therefore, the gradient of AB is equal to the gradient of CD, and the gradient of BC is equal to the gradient of AD. Therefore, opposite sides are parallel. Therefore, it's a parallelogram. Now just on that, if you had to prove a rectangle, you could do exactly the same thing, except you needed to prove it's a right angle, so therefore you needed to prove that one of the sets was perpendicular, negative reciprocal. If you were doing a, let's say just a rhombus, you would have to prove equal sides. If you were doing a square, you would have to prove exactly the same as a rhombus, but you'd have to prove perpendicular. Or you could prove that the diagonals, that to that is equal to that, so they could all be distance. Isosceles triangle, you would have to prove that that equals that, distance. Equilateral, that equals that, distance. Trapezium, just that that is parallel to that. Kite, that that and that equals, and that equals, and so forth.